Hi everyone. Today I'm going to tell you about Anova two-way classification. Okay, so Anova two-way classification in the sense here we are going to concentrate on two variables we can say, or else observations, or we can say, or else we can say in two directions we are going to analysis. Okay, so the definition is in two-way classification we take into account. That means we are going to consider, take into account two variables. Okay, so it is called ANOVA two-way classification, or else we can say this definition as in two-way classification. In two-way classification, we take into account in two directions. Okay, that means what we are going to analysis in two directions is known as ANOVA two-way classification. ANOVA two-way classification. So that means what? Two directions in the sense what? We are going to analysis in row wise and column wise. Okay, so one way is either we may analysis row or else column, but whereas two-way classification we are going to analysis in two directions, that is row wise and column wise. Okay, yeah. Now let us suppose n, capital N, okay, capital N observations, we call them as xij. Okay, so for all I equals to 1, 2 and so on up to k, and j equals to 1, 2 and so on up to n. Okay, of a random variable. Random variable which are divided into k groups. Okay, so that means nothing but groups in the sense we can call them as treatments also. Okay, so groups in the sense we can call them treatments. Treatments are nothing but procedures. What are the procedures we are going to do? Okay, so therefore we can write capital N equals to small n into k. Okay, so that means n rows and k columns, we can say. So we are going to draw ANOVA two-way classification table. ANOVA two-way classification. Here x11, x12, x13 and so on, x1 and n1 rows. Okay, these are the rows. Next, x21, that means second row, first column. x22, second row, second column. x23 and so on, second row, n2 column. Okay, so like that we can address the cell names. Okay, so at last what we can write? xk1, that means what? Here xk rows, first column. Okay, next xk2, xk row, second column. Okay, So next xk, nk. Okay, and so on. Sorry, here we can write xk n3 and so on. At last what we can write xk nk. Okay, so next total. Here total we are going to write. So here total t1 dot in the sense we are going to add, we are going to make total only in row wise, column wise we are not going to do. That's why we kept here dot. Okay, so next second one t2 dot and so on. Last one tk dot, and here mean means what we can write. So x bar 1 dot, x bar 2 dot and so on, x bar k dot. Okay, this is row wise analysis. Now we are going to do column wise, that means this side. So total what we can write here, total t dot 1. Why? Because here we are going to do only column wise. So that's why in place of row we kept a dot. In place of column we have written the name of the column 1. Okay. So t dot 2 and so on. At last t dot k. And mean means what? X bar dot 1, x bar dot 2 and so on. X bar dot k. Okay, so this is the Anova two-way classification table. Okay. Okay, so now we are going to write the Anova two-way classification equation. So what is Anova two-way classification equation is? So we say it as xij equals to mu plus alpha I plus beta j. Okay, we call it as equation 1. Here epsilon ij also will be. Okay, so we call it as equation 1. xij equals to mu plus alpha I plus beta j plus epsilon ij. Okay, where mu equals to general mean, alpha I equals to mu I plus mu, beta j equals to mu dot j minus mu. You can keep here dot, mu I dot you can keep, or else mu I simply you can write. Okay, next epsilon ij is error effect. Okay, so this is about the equation. So now we have to find out the values mu, alpha I and beta j in equation 1 can be estimated. Why? Because these are the unknown constants. We have to estimate. Can be estimated by using, so we all know unknown values are estimated by using the method of principle of least square. Okay, by using the principle of least square method. Principle of least square method. Okay, so what is the principle of least square method? Definition is nothing but, or we can say rule, summing and squaring between observed and expected should be minimum. Okay, so this is the rule of what? Principle of least square. That is what? That is E equals to double summation. Why? Because here summing and squaring we told no. So double summation I equals to 1 to k, j equals to 1 to n, epsilon ij square. Okay, so E equals to double summation epsilon ij means what? We can, from this equation, what we can write epsilon ij? Epsilon ij equals to xij minus mu minus alpha I minus beta j. Okay, we can say the value of epsilon ij. So here I am going to write that one. So this one I am going to keep here. So that is xij minus mu minus alpha I minus beta j whole square. This is equation 2. So now what we have to do is differentiate equation 2 with respect to mu. Okay, now differentiate the above equation 2 with respect to mu. That means what? dE by d mu equals to 0. That implies dE by d mu equals to, that means in place of E, what we have to keep here? In place of E, we have to keep this equation. That means what? Double summation xij minus mu minus alpha I minus beta j whole square equals to what here? 0. That means here we are going to differentiate with respect to mu itself. Okay, so that's why. So this is in the form of x square. What is the differentiation of x square? Is nothing but 2x. Okay, so that's why here 2 into double summation xij minus mu minus alpha I minus beta j whole to the power of 2 minus 1. Okay, x square differentiation is 2 into x to the power of 2 minus 1. No? So 2 minus 1. We are doing with respect to mu. So what is the coefficient of mu here? Minus 1. So that's why minus 1 equals to 0. So this 2 and this minus, if we take from this side to that side, that means from LHS to RHS, it becomes 0. So that's why summation xij minus mu minus alpha I minus beta j whole to the power of 2 minus 1 is nothing but 1. Okay, so that equals to 0. Okay. So now what we have to do in the next step? We have to multiple this term with the whole terms. Okay. So that means summation, we can, so I am going to write here summation, double summation xij equals to double summation mu. So here these are in negative. If we take from LHS to RHS, it becomes positive. So that's why directly I am going to write all these in right side. Okay, plus double summation alpha I plus double summation beta j. Okay, so now what we have to write? Double summation xij equals to here mu value, here alpha I, here beta j. See, here we are going to concentrate only on mu. That means other alpha and beta j values will become 0. Okay, so that's why only this value we are going to concentrate. So it becomes what? Double summation xij equals to double summation mu plus 0 plus 0. Why? Because as I told you that we are going to concentrate only on mu. So that's why here alpha and beta values becomes 0. That means we are not going to do any analysis regarding alpha and beta j. So that's why we have to keep those as what? 0, or else we can say those are independent variables. So that's why we kept those values as 0. You can also think like that, in that way. So, and the next is summation, double summation xij equals to, so this is mu, no? So I am making it as constant. That means summation before I am going to write. So double summation here, anything is not there means we can treat it as 1. Okay. So double summation xij equals to mu. Here what are the limits? I equals to 1 to k, j equals to 1 to n. So I am going to remove this summation. So that's why here what I am going to write is double summation, summation I equals to 1 to k, and in place of this I am going to write small n. Okay, I am going to remove this summation and I am writing here n. Why? Because in place of 1 what we can substitute n. So that's why here one summation has removed and I wrote this one. So we all know that capital N is nothing but double summation n. Okay, so that means in place of this what I can write? Capital N. So double summation xij equals to mu into capital N. So here now we want this mu value, no? So mu equals to this n comes this side. That means it is in the form of multiplication. When it comes here, it becomes division. So 1 by n summation xij. Okay, so this is the value of mu, or else we can write this as mu equals to x bar double dot, you can write. Okay, so this is about what? This is about mu. And next, now differentiate. Now differentiate equation 2 with respect to alpha I. So now we are going to differentiate equation 2. What is equation 2? So this is equation 2. So this one we are going to differentiate with respect to alpha I. Okay. So that means dE by d alpha I equals to 0. That implies d by d alpha I. In place of e, we have to keep equation 2. What is equation 2? Summation, double summation xij minus mu minus alpha I minus beta j whole to the power of 2 equals to what? 0. So it is in the form of x square. So the derivation of x square is nothing but 2 into x to the power of 2 minus 1. Okay, so that's why 2 into double summation xij minus mu minus alpha I minus beta j whole to the power of 2 minus 1. So we are going to differentiate with respect to alpha I. So what is the alpha I coefficient? That is nothing but minus 1. So minus 1 equals to 0. Okay. So and the next here, here 2 and this minus 1 I am taking from this side to that side. It becomes 0. So double summation xij minus mu minus alpha I minus beta j whole to the power of 2 minus 1 is nothing but 1. So that equals to 0. So now what I am going to do is, here this double summation I am going to multiple with this term. So double summation xij equals to double summation mu. So I am taking from LHS to RHS, it becomes positive, plus double summation alpha I plus double summation beta j. Okay, so now as we know that we are going to concentrate here alpha I, so beta j becomes what? 0. So double summation alpha I, double summation xij equals to mu into double summation 1 plus alpha I into double summation 1 plus this value becomes what? 0. So double summation xij equals to, so mu into this one we can write what? Capital N. Okay, capital N. Why? Because here we did not two summations we removed. At last we got what? Capital N. So that's why now directly I am going to write this as capital N. Okay. So place this also double summation, we can write what? Capital N. So capital N into alpha I. So double summation xij equals to, so I am going to make common. N I am taking common. So mu n common, mu plus alpha I. Okay. So now what we can write here? So n value we can bring from this side. So it is in the form of multiplication. When it comes here, it becomes division format. So that means mu plus alpha I. So mu plus alpha I equals to 1 by n summation, double summation, no? So double summation xij. Okay. So now we want what? Alpha I. So alpha I equals to 1 by n double summation xij minus what? Mu. Okay. So minus mu. So mu, what is the value of mu? Here we got x bar, mu value x bar double dot. Okay. So alpha I equals to 1 by n, we can write nk, isn't it? We all know nk double summation xij minus x bar double dot. The value of mu is x bar double dot. So alpha I equals to 1 by nk into, so I am going to remove one summation. In place of this, what I can write? N. So summation xij into n. So this n and this n becomes cancelled. So x bar double dot. So and the next is alpha I equals to 1 by k summation xij minus x bar double dot. So what is the value of these? Nothing but we can write x alpha I equals to x bar I dot we can write. Okay. So minus x bar double dot. This is a formula. So this is the value of alpha I. So similarly you can write beta j equals to what we can write? X bar dot j minus x bar double dot. Okay. So beta j. So now what we have to do is now substitute mu, alpha I and beta j values in equation 1. So what is equation 1 is nothing but xij equals to mu plus alpha I plus beta j plus epsilon ij. So now we are going to find out this epsilon ij. So that's why we are going to substitute mu, alpha I, beta j values. So xij equals to, what is mu value? X bar double dot plus alpha I value what? X bar I dot minus x bar double dot. This is alpha I. What is beta j value? X bar dot j minus x bar double dot plus epsilon ij. So now we want epsilon ij values. So for that what we can do is here x bar double dot, this value and this value minus no get cancelled. So the remaining term is epsilon ij equals to xij minus x bar I dot. Okay, so this value becomes minus when it comes from RHS to LHS, and next this one becomes plus. Okay, plus x bar double dot, this value becomes minus x bar dot j. Okay, so therefore epsilon ij equals to xij minus x bar I dot minus x bar dot j plus x bar double dot. This is the value of what? Epsilon ij. So now what we have to do is finally, so we have to substitute mu, alpha I, beta j and epsilon ij values in equation 1. Okay. Now substitute mu, alpha I, beta j, epsilon ij values in equation 1. Okay. So xij equals to mu value so I am going to write first the equation. Xij equals to mu plus alpha I plus beta j plus epsilon ij. So this is equation 1 now. So now we are going to substitute all these values. So xij equals to, what is mu value? X bar double dot plus alpha I value is x bar I dot minus x bar double dot. What is beta j value? So x bar dot j minus x bar double dot plus what is epsilon ij value? So that is epsilon ij is xij minus x bar I dot minus x bar dot j plus x bar double dot. Okay. So xij minus x bar I dot minus x bar dot j plus x bar double dot. Okay. Yeah. So now what we are making is, we are taking only this value from RHS to LHS. So xij minus x bar double dot equals to xi dot x bar I dot minus x bar double dot plus x bar dot j minus x bar double dot plus xij minus x bar I dot minus x bar dot j plus x bar double dot. Okay. So now what we have to do is summing and squaring. Summing and squaring the above term. Okay. So that is double summation xij minus x bar double dot whole square equals to double summation xi dot j minus x bar double dot whole square plus double summation x bar dot j minus x bar double dot whole square plus double summation xij minus x bar I dot minus x bar dot j plus x bar double dot whole square. Okay. So this one we call it as st square, or else we can say sum of squares of total sum of squares we can call it as. Okay. Or simply we can say it as st square. So this one is STR square. That means what? Sum of squares of treatments. Like treatment sum of squares. Okay. So, and this one you can say it as SV square. Sum of squares of variables, or else groups you can say. Okay. So next SE square. That means sum of squares of errors. Otherwise error sum of squares also you can call. Okay. So now we are going to write the degrees of freedom and also mean sum of squares. Okay. So first we are going to write the degrees of freedom. So this is very important question. Definitely you will get in your SEM exams. For degree, finally yes. So degrees of freedom. So first one, total sum of squares total sum of squares equals to capital N minus 1. Next one. Treatment sum of squares, ST square. Treatment sum of squares equals to K minus 1. Variate or else variables. Variate sum of squares equals to small n minus 1. Next, error sum of squares. Error sum of squares equals to K minus 1 into n minus 1. Small n minus 1. Okay, now mean sum of squares we have to do. Okay, mean sum of squares. So, mean sum of squares. First one. Mean sum of squares for treatments. Okay, for total. Mean sum of squares for total equals to ST squared by capital N minus 1 degrees of freedom. Next, second one. Mean sum of squares for treatments. For treatments. Nothing but STR. Treatments indicate with TR. STR squared by N minus 1. Treatments no here. K minus 1 will write. Why? Because here treatments degrees of freedom is K minus 1. So K minus 1. So next. Mean sum of squares for variate or else variables equals to SV squared by N minus 1. Okay. Next. Mean sum of squares for errors equals to SE squared by K minus 1 into small n minus 1. Okay, this is about mean sum of squares. Now test statistic. Test statistic. So, F calculated equals to STR squared by SE square if STR square greater than SE square. Sorry, SE square. Otherwise, what we can write if it is less than STR square is less than SE square, what you will write here? SE square by, sorry, STR square. Okay. So, if it is in this case, you are going to write this one. If it is this case, you are going to write this formula. Okay. This is first formula and the next, why? Because here two formulas you will have. Why? Because you are going to do in two directions, not Anova two way. So the second formula is F calculated equals to SV square by SE square if SV square greater than SE square. Otherwise SE square by SV square when if SE square is greater than SV square. Okay. So now conclusion. Two conclusions you will have. First one is treatment. Treatment conclusion. If F calculated value less than F table. Okay. Accept H naught, that means null hypothesis. Next, second conclusion is variate. Why? Because this is two-way classification. Okay, if F calculated less than F table, accept what? Null hypothesis. Okay, yeah, this is about Anova two-way classification. Hope you all understand. If you get any doubt, you can comment. I'll try try to solve your doubt or else clarify your doubt. Okay, hope you all understand. If you are newly watching, please subscribe to my channel, share with your friends, and don't forget to like. If you like, it will reach to many students, those who are in need. Okay, so thank you. Have a nice day. Bye. Take care.